All right, your essential question for today is, what are the properties of logarithms and how do we apply them? There are three properties that I want you to get down. So if you do want to take a minute, write down 1, 2, 3 underneath properties of logarithms, because those are the three that we're going to look at. So there's three properties of logarithms, and I'm not going to waste any time. I'm just going to go ahead and jump right into it and give you those three properties. So again, if you have written it down, write down the word properties of logarithms, and then underneath it, you're going to go 1, 2, 3. And I'm going to pause right there. All right, so our three properties of logarithms are the product property, the quotient property, and the power property. The product property, all it says is that if you are multiplying, you can rewrite that as logarithms of addition. If you're dividing, you can rewrite that as logarithms with subtraction. And if it's a power, you simply move that exponent in front and it becomes the coefficient. So those are our three properties, and I've got them written on the board. But let's look at an actual example. So go ahead and take a second and write down our first example, which is log base 2 of 7x to the third divided by y. And I tried to say, let me say it again, log base 2 of 7 times x to the power of 3 divided by y. The reason why I stress that is because everything that I just said is what we're going to be using to expand it. Now, what we're going to be doing for this problem, it says that we're going to expand this logarithm. Expanding something makes something bigger. So I'm going to take this single logarithm and I'm going to expand it out into multiple logarithms. So here's what I'm going to have. First of all, I notice that I have multiplication going on right here. Log base 2 of 7 times x to the third. And I also have division going on right here, divided by y. So if I wanted to expand this, I would simply write this as log base 2 of 7, because you still got to keep the same base, because you got to have the same base. And then see, that's multiplication. So I'm going to rewrite that as addition. So log base 2 of 7 plus. The reason why I put a plus there is because of that multiplication symbol right there. Now, this is x to the third power. Well, if you remember, any power is going to go in front. So this is going to be plus 3 log base 2 of x. So that 3 comes down in front. So log base 2 of x. And then this is divided by, so remember division, you rewrite that as subtraction. So I'm going to have minus log base 2 of y. And so I'm just going to recap that again. So again, right here, the plus sign, that's because of the multiplication that we saw right here, 7 times x cubed. So that's why that plus sign is right there. This 3 is because of my exponent, the x to the third. The 3 comes down in front. This minus is because of the division that you saw, 7x cubed divided by y. And so this takes into account for everything. And so this will be my expansion. Remember, when you do an expansion, it's going to be bigger, so it's going to be expanded out. So it's a log for each one of those. So you're expanding this into multiple logs from one singular log. So you're just expanding it out. But it's done the same way each time. Just remember those three properties: product, quotient, and power. And that's how you would approach that problem. So, I mean, even if you have like log base 7 of x times y times z, what you would do for this one is simply say log base 7 of x plus log base 7 of y plus log base 7 of z. Why do I put plus signs for all of these? Because of this multiplication right there, and you're expanding it out. And so that's how you approach this problem when it says to expand a logarithm. You're going to write it out into multiple logarithms. And we're going to try another one of these right now. All right, take a second and write down this example, and it's similar. There's actually two, but I'm going to put this one up first. All right, so you've got log of 5mn. So again, if you don't want to leave that base empty, you can put that this is a base of 10 right here if you want to write that. It's not necessary. It's understood to be base 10. So if I wanted to expand this, right, this is one logarithm. If I wanted to expand it, this is what it would look like. You would have log base 10 of 5 plus log base 10 of m plus log base 10 of n. And that would be the expansion of that logarithm. All right, take a second and let's try this second one. it says expand, and it's log base 5 of 8x cubed. So for this problem, I want you to expand this singular logarithm into multiples. So here's what I would do. I would rewrite this right there, multiplication. So I'd have log base 5 of 8. So there you go, log base 5 of 8 plus. The reason why there's a plus sign is because of that multiplication symbol right there. And then y'all see that 3, it needs to come in front. So that'll be 3 log base 5 of x. And that would be my answer for that one. All right, so for your next problem, let's try doing some condensing. Now, condensing is also crucial. Now we're going to go backwards. So take a second and write down this problem. All right, guys, for this problem, what we want to do is condense it to one singular logarithm. And so what that means is I'm going to condense all 3 of these into simply one logarithm. It does have a base of 10. It's understood to be a base of 10. If you don't want to put that base there, you do not have to, but there's an understood base of 10 there. So here's what I'd have. This is 6 plus 2 log. So I'm going to make an arrow. So this 2 in front is going to become the power. So it's going to be 2 squared. And so I'm going to rewrite this as 6 times 2 squared divided by, because of this minus sign right there, that's division, divided by 3. And I know that you could simplify that if you want to, but I don't want you to simplify it right now. I just want us to be able to write down the properties. I know I could work this out, but I don't want to do that. That's just me wanting to see if I know how to rewrite it and condense it down. It'd be no different if I would have given you log of x plus 3 log of y minus log of z. The way you would condense this would be log of x times y to the 3rd divided by z. That's how you would approach that problem right there. But so that's exactly how you would do that right there. All right. So for your next one, let's take a look at this one, and then let's also take a look at this one. All right. Let's take a look at the top one first. So it wants you to condense this logarithm, log base 5 of 7 plus 3 log base 5 of t. Remember, any number in front becomes the exponent. So you see how I drew my little arrow right there? So I went ahead and draw my little arrow back there. That's going to be my exponent. So here's what I'd have. I'd have log base 5, because you're condensing these 2 logs into 1, and you'd have 7, and you see that's plus. So it's going to be 7 times t to the 3rd power. So it would be 7 times t to the 3rd power. So I'd have log base 5 of 7 times t to the 3rd power. And that would be my condensing. That would be my answer for that problem. For this next one, 3 log base 2 of x, you see that minus sign right there? That lets me know I'm going to have division. That means I'm going to have a quotient. And then you see that plus sign right there? That lets me know I'm going to have a product. That's going to be multiplication. And you see this 3 that's in front, it's going to become the exponent. So you're going to condense you see all 3 of these logs are the same base. So you're going to condense that down into one logarithm. So just log base 2. You know you're going to have a quotient, so you might as well go ahead and draw your little fraction bar. There's my quotient. In the numerator, you're going to have x to the 3rd power. In the denominator, you're going to have 4 times y, because it's plus, that plus right there. So that's what you're going to have, log base 2 of x to the 3rd, and then 4 times y. And that will be your answer for that one. Let's try a couple more, and here's the first that I want you to try. So go ahead and take a second and write down this. I'm just going to put example. And so take a second and write this one down. Put down log base 5, and put down z, and then put the 4th root of x times y. And I'm going to rewrite that again so you can see it. So log base 5 of z times the 4th root of x times y. And so that's the 5th root right there. So that was the 5th root. The base 5. So that's log base 5 of z times the 4th root of x times y. All right, so for this problem, what I want you to notice, guys, is this part right here. If you want to circle this, you can. But if you notice, that's the 4th root of x times y. What's the understood exponents on the x and the y inside that radical? 1. So, guys, put a 1 right there for each one of those. That's crucial because we're going to rewrite this as exponents, okay? So not as a root. So, guys, this is the same thing as log base 5 of z times x to the 1/4 times y to the 1/4. You haven't expanded it yet. All you've done is rewritten that radical. You see the 4th root of x times y? You've rewritten those as x to the 1/4 and y to the 1/4. Now you can expand it. So look at what you've got. You see you've got multiplication. So how are you going to rewrite those multiplications right there? Addition. Where should these 1/4 go since they are the powers? Where should they go? In front. Now here's what your answer would be. You'd have log base 5 of z, right? There's nothing with that. Log base 5 of z plus 1/4, because it goes in front, log base 5 of x plus, because of that multiplication, 1/4, because that power of 1/4, log base 5 of y. And that would be your answer for that. So simply just put the 1/4 out in front for each of those. All right, take a second and try this one out below that. So I'm going to pause. So log base 2 of w square root of u times v. All right, take a second and try that one out. I'm going to pause for a second. All right, so for this one, what I need you to notice is this is an understood root of 2, so you can put a 2 there, and these are understood powers of 1. So you would expand this. Here's what your answer would be. It would be log base 2 of w plus 1/2 log base 2 of u plus 1/2 log base 2 of v. And that would be my answer for that. If you're wondering where that 1/2 comes from, it's because it's the square root of u. That would be u to the 1/2, or the square root of v. That's v to the 1/2. That's where those 1/2s are coming from, because 1/2 represents square root. And so that power comes down in front. And so that's expanding it, right? Taking a small logarithm and expanding it into multiples. So let's try one more and show you where you condense it down. And so it's the same type of problem, but let me just write down another one. All right, so let me arrow down. All right, so take a look at this one. Here's my last example. Let's say that I give you 3 log base 8 of z plus log base 8 of x over 4. And then I'll ask you to condense this logarithm. Condense it means you just want one logarithm. Well, you see you've got 2 logarithms. So when you condense this, you're not going to have 2 logarithms anymore, you're just going to have 1. But here's the kicker. When you wrote this down, guys, you see this log 8 of x over 4? If anybody's never told you this in algebra, if you have x over 4, that's the same thing as 1/4 x. If you have x over 3, that's the same thing as 1/3 x. If you have x over 5, well, that's the same thing as 1/5 x. So guys, I want you to understand that this right here is the same thing as 1/4 log base 8 of x. Those means the same thing, and so that's what I need to do first is rewrite that. And so now that I've rewritten it, I can condense this down because I know right here this number in front is going to become the exponent on that x. This 3 is going to become the exponent on that z. And so here's my answer. I'd have log base 8 of z to the 3rd power times x to the 1/4 power. And that would be my answer right there for that one.